Hello everyone, Engin, Head of Engineering. Today, together with you, we will conduct a detailed examination of the PCB I have here using our X-ray machine. In X-ray inspection technology, X-rays are used to visualize the internal structure of target objects and products. Today, X-rays are widely used in many different sectors such as medical, industrial, and aerospace. In PCB manufacturing, visualizing the internal structure of the PCB you see in my hand, determining the accuracy of the components, and examining the quality of the soldering is only possible with X-ray. Now, together with you, we will perform a detailed analysis of the components on the PCB in my hand using our YXLON Cougar Evo machine. I'm placing the board into the machine and closing the lid. And now I'm activating our X-ray machine. We can see the images of the 3 PCBs we placed inside our machine on the screen. Our goal here is to use X-ray to perform a more detailed analysis in areas we can't see with the naked eye. Now, I'll show you an example. As you can see, I'm zooming in to do a detailed analysis of the BC section here and checking each section. As you can see, each section has been soldered very neatly. Then I move on to the other PCB. To the same spot, the same component. Here too, as you can see, I can very clearly see that there is a problem in one of the sections. On the other PCB, as you can see, there are short circuits between the B and C sections. Unfortunately, it's not possible for us to detect this fault without using the X-ray machine. Therefore, this component either needs to be repaired or replaced. After completing our detailed analysis, we now move on to the reporting stage. We mark the spot where we detected the fault. Afterwards, we turn off the X-ray and take our PCB out from inside. As you can see, there's an indicator on the door, and we can only open the door once it turns from red to green. Now it's turned green, so I can open the door and take my PCB out from inside. After carefully taking my printed circuit board, if there is a unique barcode present on the surface of the PCB, we can then automatically and efficiently record our specific identification number here using the specialized handheld barcode reader device. If not, you can also perform this process manually. I'm saving my report, and to review my report, I open the page where I saved the report. As you can see in the report, you can view on which date, at what time, with which barcode number, and which operator performed this process. Here as well, as shown in detail on the image, you can see exactly at which point the problem occurred, and from the information here, you can also see in detail which voltage and current we used while detecting this problem. In cases where 2D images are not sufficient during analyses, we obtain 3D images using the laminography option available on our machine. Now, let's take a look at the 3D images together. Engineer Mr. Alperin is at the laminography table. What processes are we carrying out?
Thank you, Mr. Engin. Right now, in the three-dimensional environment, we are checking parameters such as the shape of the solder, the amount of air inside the solder, and the solder joints.
As Mr. Alperin explained, performing 3D image analysis is extremely important to prove the reliability of solder joints. With 3D image analysis, we can thoroughly analyze solder joints, contact surfaces, voids inside the solder, and mechanical cracks in detail. Thank you, Mr. Alperin. During electronic board production, checking the quality of each individual board is extremely critical. With the X-ray system in our facility, we can perform 2D and 3D analyses to detect possible early faults. We don't just use our X-ray device to inspect electronic boards. At the same time, we can also analyze any mechanical or electronic component. As you can see, we are going to analyze a mechanical part used by our R&D department. we will take a detailed image of the windings inside the plastic component. At the same time, we will also analyze a non-functioning cable with our X-ray device. Now, let's examine these two parts together. Let's start with the analysis of the mechanical part. As you can see, we will perform a detailed analysis of the windings inside the mechanical part. For this, we will use the tilt option and examine the windings at an angle. As you can see, with the help of both the tilt option and the voltage and current values we used, we obtained a very clear image. Finally, let's analyze the non-functioning cable. As you can see, we can very clearly see that there are breaks in the cable. Today, we provided you with detailed information about the X-ray machine and its options. In the future, we will also present detailed explanations of the other machines in our facility. See you in the next videos.